Hello, welcome back to Daily LeetCode Live. We'll get started with the daily question. So what do we have today? We have maximum ascending subarray sum. So given an array of positive integers nums, return the maximum possible sum of an ascending array in nums. An ascending array is defined as this. So if OI where right, so I would be the index anywhere from L to R, exclusive on the right side. Nums I is strictly smaller than I plus 1. So basically means that the subarray has to be strictly increasing. Note that a subarray of size 1 is ascending. Okay. Right. Yeah, also subarray is it has to be contiguous. So you can't have like the array here, like you can't have 10, 30, 50 because like they're separated. So yeah, let's think about how we can do it by looking at the examples. So first of all, you can definitely use brute force to find where the increasing subarrays are, and whenever you have a break like this, so this is not ascending anymore, right? You can never, like the largest ascending subarray could never have these two elements together. So you definitely have a cutoff. So let me draw the example out. So you have 10, 20, 30, 5, 10, 50. The maximum subarray definitely cannot contain these two elements like at the same time, right? So we can have a cutoff here, and after we have a bunch of cutoffs, we can just find which subarray is the biggest. And yeah, I think that's the solution. Yeah, let's have a look. Yeah, I'm pretty sure that's the solution. So we can find all the breakpoints. So breakpoints for locating where which adjacent pairs of number are not strictly increasing. So for I in range, of course, we have to set n as the length first. So if nums I is not small, it is not strictly smaller than I plus 1, well, then we found a breakpoint. So breakpoints depend. Actually, whenever we use breakpoints, it's actually cleaner to write it in like with exclusive points. So what I mean is, so we know that like 30 and 5 has a breakpoint, right? But this is in between the second and the third element, and it's always better if we use this as the breakpoint. Well, at least like this is what I like more, because when you're looking at the breakpoints array, so it would be like 3 and 6, like we always at the end as well. We can just have like a variable called starts, and then like our n would be the breakpoint number, and so the range we are looking for is just this, and then next time we can just set this as like the starts. well, the other way works as well, but I like doing this way more. So, um, yeah, I'll just change that, and I'll make this I minus 1 and I. And then we can just append I here. And of course, at the end, we also want to append n, because, well, like, let's say for this one, right? All of them are strictly increasing, but this is really one array, right? So we want to add the breakpoint at the end to account for that as well. So we have start at 0 for breakpoint in breakpoints. Our end, we don't need to set the end. Yeah, that. We just want to get the sum. So subarray sum, and then we want the max subarray sum here, of course. So for I in range start to the breakpoint. So this is why I like the breakpoints being exclusive rather than inclusive, because we can use range here and it just works so nicely. Well, we can just add the number. We can just add the elements of that subarray, and after we add all of them, we just check whether the subarray, like the current subarray, has a larger sum than the current running maximum. So we can just do something like this, and then, well, we want to set the breakpoint, the current breakpoint as start, and yeah, that should give us the answer. Let's see if we make any bugs. Don't think so. Nice. I'll see you guys tomorrow. Bye.